Good morning again, everyone, and welcome to the webinar. Let's get started. Before starting, some technical rules. You can activate your camera yourself, while the microphone can be activated only by the organizers. So if you have technical issues, please write it in the chat. If, however, want to ask questions, you can either write in the chat or raise your hand, and we will reactivate the microphone. Moving on the content. It's a real pleasure to introduce the webinar on digital platforms developed within two European projects, FLEXIndustries and TRINEFLEX, that 4 years ago were selected under the same call, European call that funded projects combining digital technologies with green and circular innovative solutions to help the EU climate neutrality. This neutrality is becoming more and more urgent today, especially in the current context of geopolitical, economic, environmental, and social crisis. So these interconnected challenges require coordinated and forward-looking actions, both at European and global levels. In this scenario, obviously, research and innovations can play a crucial role in supporting objectives of such as the Green Deal, the Industrial Clean Deal, etc. In fact, new technology and scientific knowledge are essential to find sustainable solutions, sustainable innovations, and to accelerate the energy and ecological transitions. But at the same time, the strongest synergy with industrial sectors is equally important. Indeed, research and innovations can generate real impact only with a strong synergy as taking into account the industrial needs, the market requirements, and the political regulations. So only, I think, through these joint efforts and collaboration, it is possible to transform today's challenges in opportunities. So speaking about collaboration, I want to highlight that even if each project follows its own specific objective, a common collaboration and common vision was shared from the very beginning. Over the years, it's a big, long journey of collaboration and sharing vision between the projects. Also with another one, Flex for Fact, that has already concluded in November last year. We organized together an event each year. The first one is a joint seminar in October 2023, then a workshop involving stakeholders to discuss on benefits, challenges, future strengths of digitalization, process optimization, and energy flexibilities. After we participated to the Elite exhibition, so an expo on energy transition in Bilbao, Spain last year. And finally, this webinar was able to lead to the joint presentation of the results achieved by the two different projects, again, FLEXIndustries and TRINEFLEX. So today webinar, I think that not represents only an opportunity to present the digital platforms, but also to gather feedback from the stakeholders. And we hope this webinar will provide useful insights and open up to further opportunity for collaboration between different stakeholders, research, industries, and so on. So thank you again for attending this meeting, this webinar, sorry. And now it's the turn of the first speaker, Arif Pasha Mohamed from Hymen, Spanish Technology Center. Arif is the project coordinator of TRINEFLEX, and today you will present the TRINEFLEX approach. So just one thing before to start, we have also scheduled a few minutes for questions after each session. So again, please, if you have some question, you can write on the chat. And yes, Arif, it's your turn. Thank you.
Thank you, Michela. Let me take over now. Okay, as Michela already introduced myself, so I'm Asif Mohamed. I'm project coordinator of TRINEFLEX from Hymen Technology Center. Today I will be speaking about the approach that we followed in the project on the digitalization topic. So digitalization of energy intensive industries and our approach. So the digital transformation of energy intensive industries requires a systematic methodology to ensure the effective integration of digital technologies into existing demo case infrastructures. During the start of this project, we understood that these industries face increasing pressure to adapt digital solutions, mainly to enhance efficiency, reduce costs, and support the sustainable practices coming from the European Commission. So to address this challenge, TRINEFLEX has developed and tested a structured approach that facilitates this systematic digital integration. So this proposed approach is organized into sequential, but also interconnected stages, which I will go through in my next slides. So starting with the objectives. So it's important that we understand clearly the objectives of each use case in the project. So the process commences with the definition of objectives for the demonstration case, for the industrial cases. So these objectives provide the strategic framework within which digital interventions are designed. So I will go here. We have 5 demo cases in the project. Verallia from the glass industry in Italy, Refial aluminium recycling in Spain, Esamur, a wastewater treatment plant in Spain, Halcor, the copper industry in Greece, and then we have ADAP again, another wastewater treatment plant in Greece. So the first stage here is to understand the objectives of each demo case. In case of Verallia, they want to reduce the energy amount required, increasing energy efficiency, implementing electricity sources instead of natural gas combustion. And then we have Refial focusing on reducing the energy consumption in their rotary furnace, evaluating the use of hydrogen as an alternative source energy. And then for the Esamur wastewater treatment plant, their objective is to reduce the energy consumption, increase energy flexibility, implementing the use of renewable energy. And for Halcor, acquiring deep monitoring insights, increasing the equipment availability, flexibility, and efficiency and reliability, and maximizing the energy and feedstock flexibility. And for ADAP, enhancing energy efficiency, reducing energy cost, lowering the emissions. So we started with these objectives, and the next step is to analyze the digital requirements. So a comprehensive digital analysis was conducted for these objectives to determine the digital infrastructure of each of these demo cases their tools, the skills necessary to achieve those objectives. So this stage provides the foundation for selecting appropriate technology intervention. So what we did here is try to understand the current digital maturity of each industry. How are they? Are they advanced? They need a lot of things and so on to make a use of the developments that will be made in the project. And then we have the understanding the operational bottlenecks, trying to find some opportunities for the energy optimization, trying to also see what are the gaps for integration, and are there any automation potential. So for example, there are a lot of industries that still use manual work, paperwork, to record some things, and we also try to see if we can automate some of this, and then analyze the use of AI and ML applicability in the demo cases, trying to also understand the communication and connectivity issues in each of the demo cases, cloud requirements, and so on. So during this stage, this analysis stage, we try to completely understand each of the demo cases, linking them with the objectives and what needs to be done and so on. So once this analysis phase is completed, then comes the retrofitting, which is an iterative with the analysis. So here, what we try to do is, rather than replacing existing equipment, the digital retrofitting, it tries to integrate sensors, connectivity, and automation into legacy systems. So instead of completely replacing it, try to see if we can upgrade it to an extent that will be useful for collecting the data and so on. So this cost-effective approach maximizes asset utilization when enabling real-time data acquisition. So here we have some examples of different hardware and software components that were retrofitted, or some of them are replaced. And then comes the data collection. So once we retrofitted the equipment, the devices, the systems generate a continuous flow of data, so which is collected, standardized, and securely stored. We have 5 demo cases in the project, so each one has their own data collection methodology or systems. So we need to understand each demo case, how they want to, and then we have to standardize. And we have a platform called Caron that enables the easy collection of this data. So these robot data management systems are provided for the partners, for the use cases, to implement and to ensure the integrity, accessibility, and interoperability of the data that's generated by these different systems from the demo cases. Then comes the data analysis and the decision making. I'm going to go very fast on this slide because the next 2 presentations from my colleagues, George and Alejandro, will focus more onto the infrastructures that were developed in this one. So analytical methods are applied to the stored data in Caron platform. Insights were derived at this stage, and trying to inform and form optimization strategies, identifying inefficiencies, and forecasting potential improvements. And then the decision making here leverages the insights from data analysis to support evidence-based decision making. This ensures that strategic and operational decisions are informed by reliable data-driven evidence. And here we have developed an infrastructure called TRAIN, and this is a TRAIN analytical infrastructure which enables partners to run their tools without any cost from the demo cases, because this is a research project. So we try to demonstrate that this is one of the possibilities for the demo cases if they want to go for cloud infrastructures in the future. And then we have this decision support system, which collects all the data and all the information from different tools and try to display and make it visible to different levels of the users in the use case. And then during these different stages, there were lots of tools developed. So at each stage, tool developments supported the implementation. These include like the retrofitting solutions, like hardware and software, and it also includes the analysis tools, the dashboards, and so on that facilitate the user-friendly interaction with complex data sets. So these tool developments were iterative, informed, and updated by the evolving needs of the demo cases. This is a list of tools for each of the demo cases that were developed during the timeline of the project. So currently they are in the validation phase, being tested and used by the industrial use cases. And in parallel, we also have some transversal tools that help these individual tools. And finally, a significant contribution of this approach is also to record the lessons learned and focus on the transferability or on the replicability of what was developed during the project. So lessons learned from demo case reveal that the methodology is adaptable across industrial sectors, and we have come up with a list of tools that could also be replicated, not only in the same domain or sector, but some of them could also be interesting for other domains and sectors. So this is the TRINEFLEX approach that we followed during the timeline of the project, and so far this has worked, and we are currently in the final stage, that is the validation stage, where we are testing and making sure that all the tools will be working and be replicated. Yeah, that's all from my side. Michaela, over to you.
Thank you, Nazif. If someone has any questions, or you can write in the chat also after, and then so we will go more in depth to the digital platforms developed in TRINEFLEX. So now I give the floor to George Bayard, Senior Research and Development Operation Engineer at University of Thessaloniki in Greece. He'll present TRAIN, one of the TRINEFLEX platforms, an infrastructure enabling the digital transformation of energy-intensive industries. So, George, the floor is yours. Thank you.
Thank you, Michaela. So, hi, everyone. I'm George Vlachavas. I'm from the Aristotle University of Thessaloniki. Today, I'd like to talk to you about TRAIN, the analytical infrastructure that we developed within the TRINEFLEX project. Specifically, I'd like to explain what it is, how it was built, what it achieved, and why it matters beyond the project itself. So let me start with some context. Energy-intensive industries are under increasing pressure to digitalize, to adopt advanced monitoring tools, optimization algorithms, decision support systems, and more. Many are already doing this, but a common pattern emerges. The technology exists. Pilots get started, results look promising, and then things stall. Why does that happen? It's not because the tools don't work. It's because the environment they need to run in isn't ready. You end up with multiple technology providers that don't talk to each other, servers set up on an ad hoc basis. There's no clear process for updates or maintenance, and real concerns about cybersecurity and compliance exist.
Sorry, George, to interrupt you. We hear some noises with your microphone. Would it be possible to change it to remove the AirPods? Because it's not like the noise is quite disturbing. If you can just remove the earphone. Thank you. That would be appreciated.
Is this better?
Yeah, definitely better. Thank you.
Okay. I switch microphones. Okay. Okay. Sorry about that. Where was I? So each tool ends up living in its own contained silo, maintained differently, accessed differently. There's no common operational logic holding it all together. The result is that even with individual digital tools performing well, the overall digitalization effort remains fragile. It depends on specific people, specific setups, and informal agreements that don't scale. Moving from one pilot to 5 pilots, or from 5 tools to 15, it becomes too complex to manage. This is the problem Train was designed to address. Train is a methodology and an operational framework for setting up a secure, virtualized infrastructure that supports the deployment of digital solutions from multiple technology providers in a structured, maintainable, and scalable way. It's not a software application or a dashboard. It's the layer that runs underneath those that makes everything else work. So what does Train offer in practice? Well, at its core, Train provides a set of capabilities that industrial environments typically lack when they start digitalization. Let me go through the most important ones. Digital solutions are deployed as containers. For those less familiar with the term, containerization means that each application is packaged together with everything it needs to run. This makes it portable, consistent across different environments, and much easier to manage. In an industrial context, this is significant. It means a solution developed and tested in one environment can be deployed in another one without unexpected failures or lengthy reconfigurations. Updates are handled through automated CI/CD pipelines, so there's no need for manual intervention every time something changes. This might sound like a technical detail, but in practice, it's the difference between a digital tool that stays current and secure versus one that gradually drifts out of date because nobody has time to maintain it properly anymore. Each technology provider gets their own private registry. This is a control space where their software is stored and distributed. This matters for both security and intellectual property. Partners can deploy their solutions without exposing their code to others on the same infrastructure. There's also centralized logging and monitoring, so you always have visibility over what's running and how it's performing. And access control and firewall mechanisms ensure that different partners can collaborate without exposing sensitive data or sensitive services unnecessarily. Finally, the virtual machine-based architecture means that the infrastructure can grow. You're not locked into a fixed setup. New services, new use cases, new partners can be added without rebuilding everything from scratch. Within TRINEFLEX, Train was designed, fully deployed, and put into operation by the Aristotle University of Thessaloniki. The infrastructure currently consists of 7 virtual machines. One handles shared services and project-wide workflows. 5 are dedicated to the 5 industrial pilot environments in the project, each with its own isolated space for deploying and running use case-specific services. And 1 runs Jenkins, which manages the CI/CD pipeline part across all use cases, automating the process of building, testing, and deploying updates. Docker was deployed on each machine, alongside an Nginx reverse proxy for managing how services are accessed, firewall configurations for security, and watchtower service in each VM for automatic container updates. What I want to highlight here is that this is a real deployment. It's not a proof of concept or a theoretical design. Every component was configured, tested, and used in practice to support the project's digital services over an extended period. The architecture diagram gives you a sense of how these components connect and communicate with each other. And the results reflect that. Across the project, there are 77 services that were deployed on Train. These are from 7 different technical partners running across 5 industrial pilot environments. That's really not a small-scale test. It's a complex, multi-provider digital ecosystem operating on a shared infrastructure. The partners involved were IMAN, AUTH, ICCS, ITERNER, NORSE, SCCH, and TAU, each with their own technology, their own deployment needs, their own security requirements. Train had to accommodate all of them within a common framework while keeping their services appropriately isolated from each other. In practice, that meant each partner had their own private Docker, as I said before. Every partner has their own. If the partners don't have static IPs, some of them have, but some haven't, which is common in research and industrial settings. They could still access the infrastructure securely. Sensitive services were kept restricted, and the system is continuously patched and updated throughout the project lifetime without disrupting services that are already running. So we have digital tools that actually operate in a shared industrial environment, not in isolation, not as one-off pilots, but as part of a coherent, maintained ecosystem. The complexity here is there, it's real, and we managed to maintain it with Train. This brings me to an important note. Train is a key exploitable result of the TRINEFLEX project. This means that what we're offering is not just a description of what we built. It's a transferable package of know-how that another organization could take and use to build something equivalent. That package has 3 layers. First, there's operational procedures, how you onboard new partners securely, how you handle incidents, how you manage backups and recovery. These are the processes that keep an infrastructure running reliably over time. And they're often the hardest thing to get right because they require operational expertise that can be easily improvised. Second, there's DevOps workflows, the CI/CD pipelines, the Docker files and deployment configurations that were used throughout the project. These are the practical tools that make day-to-day operations sufficient. And third, there's infrastructure as code, the engineering configurations, the registry integrations, and reusable templates that define how the environment is set up. This means the infrastructure can be reproduced consistently, documented clearly, and handed over without depending on the knowledge of a single person or a single team. Together, this gives you the blueprint of and the tooling to build an industrial-grade digital infrastructure, not from scratch, but based on something that has already been validated in practice. So who's this relevant for and why? Well, if your organization is looking to integrate multiple digital technologies from different vendors for different use cases, Train offers a way to do that without creating a fragmented mess of isolated deployments. That methodology is vendor agnostic, so you're not forced into a particular technology stack or supplier relationship. From an operational standpoint, having standardized onboarding and deployment processes means that bringing a new tool into production is faster and it's less risky. Monitoring and automated updates mean that you're not constantly firefighting. And because the architecture is designed to scale, what works for one pilot can grow into something that supports an entire digital program. For industries where security and compliance are non-negotiable, and in energy-intensive sectors, they usually are, Train provides the access controls, the firewall mechanisms, and documented procedures to operate with confidence. So closing, we talk about a lot about twin transition, the need for industries to become simultaneously more digital and more sustainable. That's a real and pressing challenge, but it's easy to focus on the endpoint and underestimate what it takes to get there operationally. Train is a contribution to that foundation. It enables industries to deploy digital solutions securely, bring multiple technology providers into a common environment, and move from isolated pilots to something that runs continuously and at scale. It has been built, it has been tested, and has been validated within TRINEFLEX. And as a key exploitable result, it is available as a transferable methodology for any industrial stakeholder looking to build that kind of digital backbone. Well, thanks everyone for listening. I'll be happy to take any questions now.
Thank you, George. Some more questions? Please write in the chat or raise your hand. No questions so far. So maybe at the end of the presentations, and then we move to another platform in TRINEFLEX. So now is the turn of Alejandro Gomez Gutierrez, software developer at Edener in Spain. He'll talk about the decision support system platform developed at in Train. So Alejandro, is your turn. Thank you.
Thank you, Michaela. Good morning, everyone. In this presentation, I will introduce the TRINEFLEX DSS platform and explain its role as digital environment for integrating data, models, agents, and user interaction. The objective is to show how the DSS helps transform complex industrial data into useful information for decision-making in the context of energy flexibility and sustainable operation. The main problem is not only to collect data. The real challenge is to transform data into decisions. Industrial data is usually heterogeneous, distributed, and difficult to interpret. And the DSS becomes the layer that connects this information with other agents and user-oriented visualization. The main objective of the DSS platform is to provide a unified digital environment inside the TRINEFLEX data management platform. It's not only a dashboard, it's the human machine interface of the flexible operation DSS. Through this interface, user can access operational data, historical data, KPIs, models, and output from intelligent agents. In practice, the DSS is the visible layer that makes the project usable by industrial users. One of the more important roles of the DSS is integration. In European projects, different partners usually develop different components, like model, engines, digital twin, data service, or even specific front ends. The DSS provides a common environment where these elements can be connected and exposed to final users. Depending on the case, DSS can develop the front itself, integrate existing service, or act as a gateway to third-party interface. This avoids fragment tools and creates a coherent user experience. From a technical perspective, the DSS is designed as a modular platform. The backend is based on microservices, and this means that each functionality can be developed, deployed, and maintained independently. The frontend is decoupled from the backend and is implemented as an interactive web interface. The use of open source technology and Docker-based deployment is important because it improves portability, reproducibility, and maintainability. This is useful in TRINEFLEX because the platform must integrate heterogeneous components from different partners and adapt to different demonstration cases. In practical terms, the DSS provides a modular digital environment for decision support. It centralizes access to models, agents, and visual analytics. It can connect to Kairon or other data sources and present this information through dashboard, tables, charts, KPIs, and scenario parameters. Another important point is access control. Different users may need different views depending on their role, demo case, or process layer. Finally, the platform is designed for continuous integration because user requirements usually become clearer when the user start interacting with the system. Okay, now I will show a short demonstration video of how this costing is translated into a operational interface. This video shows how the DSS can support navigation, visualization, interaction with data, and access to different platform components. The important point is not only the visual interface itself, but the integration of the logic. Okay. Sorry. Okay, as you've seen, the video shows the practical side of the DSs. We can see a common interface that can be adapted for different users, different demo case, and different process layers. And the platform can display KPI, charts, table, and operational information in a structured way. But the most important point is that the interface can evolve through the iteration with the end users. The DS is not a closed product, defined only at the beginning. It's a modular platform that can be redefined as requirements become clearer. To conclude, the DSS is the integration and iteration layer of TRINEFLEX. It connects data source, model, engine, digital twin, and final user a single digital environment. The modular architecture, open source approach, and Docker-based deployment make the platform scalable, maintainable, and easier to replicate. This methodology is very relevant for European projects, where different partners usually contribute different tools and models. Instead of forcing our partner to use the same technology, the DS provides an iteration framework that can connect heterogeneous components and present them through a coherent user interface. For this iteration, the TRINEFLEX approach can be transferred to other projects involving data platform, digital twins, AI agents, and industrial dashboard, and this is support system. Thank you very much. This is all from my side. If you have any question.
Thank you, Alejandro. Give a few minutes for questions. Okay, so. Otherwise, let's move on to the other project, so FLEXIndustries project. So Nicolò Bertozzi and Anna Ganci from the Fondazione Links, related to Polytechnic University of Turin in Italy, and they will present the role of digital twin platforms from industrial data to smarter energy. So I'll leave the floor to Nicolò and Anna. Thank you.
Yeah, thank you very much. Good morning, everybody, of course, from my side. My name is Nicolò Bertozzi, and as also Michela said, we work in this project in FLEXIndustries. But before starting, I would like also to give, let's say, the presentation to Anna. So regarding me, I'm project manager and data engineer in Fondazione Links. So I studied in the past data science and engineering, and then I moved to data engineering only. So today we will present you what we'll do from our side, from the data engineer's point of view, okay? Not from the specific implementation, because the specific implementation is something normally vertical and not completely horizontal, and we will let you give access to multiple models in different contexts. But before starting, I will let you to give Anna some time to present herself.
Hi, thank you, Nicolò. Good morning to everybody. I'm Anna Gerardi. I'm a researcher in Links Foundation. I'm a software engineer. I studied engineering at Polytechnic of Turin, and this is my first employee in Fondazione Links. I'm very happy to work with Nicolò and my teams in digital twin architecture, and we also try to implement some cloud features and something also in this topic. So now we can start the representation in that way to be fast.
Thank you, Anna. Okay, let's just move back to the title. So from industrial data to smarter energy decisions, the role of digital twin platforms. Okay, because today I will let you present you a path, a simple path. Okay, a journey starting from the data source to the AI. And normally today we are treating the AI as a commodity, okay, as something that you can use without any problem. It's true, it's beautiful using AI. It's beautiful also probably using generative AI to build AI, okay, AI classic. But in my opinion, at the end, you will have to ensure that this AI component is deployed and is able to receive data. Okay, so this is the problem. We have large volumes of data, as known as silos, okay, that will let you transform into optimizations, into decisions, into forecastings, into AI, okay? And in order to do this, we have created a platform that is able to manage all these aspects, okay? Starting from the data storage to the orchestration. I will say you something about orchestration because some technical of you could say or could imagine that it is something, let's say, connected to the deployment. Not at all. In this case, it's connected to the cooperation of our modules and also the optimization services. So some just parts of our agenda. Main ingredient we will see, probably you can imagine with this, which is this main ingredient, and then we will speak about the platform. And finally, I will leave Anna to speak about all the services that are running in the platform that ensure a complete usability for the users, and some final use cases and conclusions. So let's start. Main ingredient, okay. Well, digital twins, probably you know, it also has been said, digital twins are virtual representations, okay. So we have something virtually that is the copy of something that is more material in the physical world. And on this digital twin, we can execute forecastings, optimizations, and so we have this object, this virtual object that is able to be, let's say, optimized, controlled, analyzed from multiple perspectives and multiple point of views. But we have one problem. The problem is that this entire flow is dependent on one single point, the data. Okay, we need to have this data. So it's impossible to run AI. It's impossible to build AI, but also it's impossible to run the AI without the data. In order to have a forecasting, we need some data, at least one tiny bit, but with listed. So no data, no party, as say George Clooney said in the advertising spot in the last years, okay, for Martini. So no data, no party. It's impossible otherwise. So let's start from this simple architecture. In FLEXIndustries, we have pilots, okay, use cases, normal, let's say, European energy-intensive industries, okay, Milois, Tomana, Sun Pharma, Ford, Fertinago, and K-Flex. They spread over multiple areas. Now, it's not important to say that Sun Pharma is a pharmaceutical company, okay, but it's important to say that they provide data. And together with our pilots, we have also other data sources. We have weather, we have prices for the energy market, for the natural gas market, and other things. So we have some adapters that are able to, say, gather this data, and they are able to harmonize the data in a common format. This is very important because with this harmonization, you can build on top of this data semantics, you can build insights, you can build storage ETL pipeline, so you can do whatever you want if you have a common format. And also you are increasing your, let's say, storage effectiveness, okay. Then after our adapters, we have database fog. This is something that is composed of multiple databases. It's impossible today to have one key for all the doors, so the passport 2, okay, one solution that fits all. So we in our platform, we would like to store the right data on the right database because that database has been built for storing that data, okay? And it's important because when the volumes continuously increase in your disk, you have to compact, you have to optimize, and the optimization is important. So this is why I'm speaking about database fog, okay? We have a mixture of databases. It's something that I normally say in this case is that we have a polyglot database, okay? Something that is able to speak multiple languages. So depending from the language, you can storage in multiple databases. And then we have a broker for the real time here on the bottom. On the right, we have two interfaces, historical and real time. So the idea is that this data handler that you can see here, this component that data handler means handling the data, okay, nothing difficult. This component is able to provide to the platform, that is, you can imagine that the platform is on the right here, okay. The platform will contact the data handler that will contact the interfaces to get the data that is stored in the right database. So with this infrastructure, we now have data harmonized in databases, the right ones, and then provided to the platform. So this is the starting point. This is our starting point. And now, on top of the data, we can build whatever we want. Okay, the journey is infinite. We can create whatever we want, and we can basically provide whatever we want to the AI, and be sure to obtain the right goals and objectives. So this is why we just created a platform oriented to multi-agent systems. Not to, let's say something critical or too important, but multi-agent systems are now well known for generative AI, but they were present also in the past years, also in the 2080s, 90s. Okay, so this is a concept that is somehow old, and this is why in FLEXIndustries, that is an Horizon project, so started several years ago, before GPT, before LLMs, FMs, SLMs, GenAI, and other things. We started deploying and thinking to multi-agent systems as composition of agents, of modules. Okay, so we are using this paradigm to coordinate the work of distributed software. So these agents are specialized in executing some tasks. This is the difference, in my opinion, between generative AI, multi-agent system today with LLMs, and what we are trying to do in FLEXIndustries. The difference is only a couple of words. Data, you already know data. Sovereignty. Okay, we don't use LLMs where they are not important, especially, of course, in Horizon projects. We, in this case, use agents that are able to execute a deterministic task, because not always, and in my opinion, in general, at least for the AI that we have today, it's impossible to give to an LLM a complete authorization on your data, and also the complete authorization of generating code for you, making optimization and other things. It is possible with some limits, in my opinion, some boundaries, but in general, data sovereignty is something that we would like to ensure, especially with industries in Europe, where they produce and they are relying completely on their data and on their production features. Okay, so in our system, we built a multi-agent system several years ago, before GenAI, but our agents are deterministic, are able, given an input, to provide an output. They could contain AI, it's not important, but they are deterministics, and they are, let's say, deployed and controlled. So these agents, in general, are able to complete a task through a workflow. A workflow is the recipe. Okay, if I start executing a workflow, I'm starting a pipeline. A workflow can be the recipe for multiple pipelines. Okay, the recipe is a apple pie, and you are able, and you can cook the apple pie how many times you want. Okay, look at the diabetes, but in general, it's the idea. In our infrastructure, so we have an orchestrator that is not the orchestrator that you could imagine from the, as I told you before, distributed deployment. It's not Kubernetes. We will use the Kubernetes, and Anna will say you everything about Kubernetes. But in this case, the orchestrator is something on the data orchestration tier. Okay, we are a little bit on top. We are not on the service orchestration. We don't have to reinvent the wheel. We don't have to create another Kubernetes inside Kubernetes. So we are leading. We are, let's say, using Kubernetes to orchestrate the services, to manage the replicas, the system, the nodes, the resources, the GPU, not GPU. Okay, this is something that we do on the bottom. But on top, we are managing flows with this orchestrator that is custom based on our platform. So what is basically, this is a coordination component that is able to manage the communication with all the agents, but also, if you remember, the data handler. So it's just a bridge, okay? A bridge between data agents, between data themselves, or data and the user, or agents and the user. It's just a collecting point, okay? So with this orchestrator, we can distribute the microservices because they could be everywhere. We have some components, then I will show you something about how we can connect the orchestrator with the various components. We have the asynchronous communications that will lead to reduce the overhead of in this case, asynchronous communications. We are completely stateless, so that we can just shut down the machine or restart the machine, and all is able to restart as previously because we use a composition of caching systems, databases, brokers that ensure us to be compliant with and fault tolerant. We can trace all what's happening. We can monitor the activities. And this is connected to debugging, of course, but if we would like to do it, also to, in this case, quoting, okay, and billing, we can do it. So with this component, we can manage everything because it is centralized. And one could say, okay, but you are centralizing the problem. So you have now a unique point of failure. Not in this case, because the orchestrator is distributed. So it's like the replica set of a database where you have multiple services that provide the read and only one the write. Here we have multiple orchestrators that are able to manage the resources, manage the request, and in case of problem, they are split. So we have a cluster of orchestrators, 1, 2, 3, and it's not important. And they are able to distribute the load through the broker. So this is the key point. The central orchestration is able to ensure the deterministic behavior and the debugging of these communications. And it is able to provide us an abstraction layer, okay? With this layer, we can be sure that we can deploy on top whatever AI. Then we have an integration of new agents in a easy way. Anna will say you something about our K-native implementation, because it's not a matter of using an orchestrator only. It's a matter of using this component together with a lot of other things that in case Anna will show you. Then we have the fallback logic that is connected to the sequencing and the handling of the data. So we are sure about what is happening, and so we are sure that a single agent is not answering. So we can just restart from the past. So with this in mind, with these features in mind, we can think that in this case, with the central orchestration, we can divide the load into multiple replicas, and we can, together with Kubernetes, we can manage these replicas. Then, using the cache, we are able to store and cache, let's say, intermediate results in these systems, so that we can restart, so that the single agent is not able to lose, cannot in general lose data or metadata or other things, because in case we can restart it and we can just retrieve from the cache what we need and what in case it needs. And exactly, this is connected to also the fallback, because since they not store data, they can be just restarted, and we can distribute the load. Also, we can manage the single execution, and in case run a complete parallel execution for the training only. Also about the training and the auto retraining, and I will say you something in the future. So all these features that you can see here could, let's say, something simple or something well known. Okay, it's true, it's true. But the key point here is that these features are enablers for other services in the platform. The idea is to provide to the data analyst, in this case to the data deployer, a complete environment, a platform that is composed of a complete environment that is able to embrace together the execution. Okay. And of course, as I told you before, the asynchronous part is important because we can have less that time regarding the synchronous communication. So in order to implement all these executions, we have to be completely event-driven. Okay, we have to ensure asynchronous communication with the cache and with the other systems asynchronously. We exchange in this way on Kafka central messages, event messages. So Kafka for us is only the source of truth for the events. Triggers, we can call them triggers. I would like to trigger an agent, I send a triggering message to the agent. I would like to trigger the orchestration part, I will send a message to the orchestrator asynchronously with Kafka. So in this case, we are loosely coupling completely the services because they are asynchronous. So they are not dependent each other. In this case, in a pipeline, we can have an agent that is triggered by the orchestrator. We send a new trigger command to the agent, and the orchestrator will wait, not wait actively, wait passively, because of course it's asynchronous. So the orchestrator will send the message, and it will completely forget to have sent the message. Whenever the agent is able to answer, the orchestrator will just resume the previous executions, and we complete the pipeline. So this is why we are saying that we are using triggers and asynchronous communications, because in this way we can just speed up our process. So in order to say implement this paradigm, this communication, we have basically three main standardized messages: orchestrator, agent, and data task. Okay, you can imagine the orchestrator is the task that we use to trigger the pipeline, data to trigger the data queries or real-time exchanges, and finally the agent to trigger the agent. Now I will show you another figure to just demonstrate what I mean. So let's start from the APIs. The APIs are our main door of our house. You know, we are using APIs to, let's say, provide to a possible user with a front end with all the usability features and requirements point of view. We have to provide to the user the functionalities, the capabilities of our platform. So the APIs are able to exchange in the communication backbone, that is this one, over Kafka, the control messages. Okay, in this case, start a new pipeline. Then these control messages will be sent over the agents, over the orchestrator. It depends. The orchestrator task is the first message. We will see something in the next slide in the figure where you can understand better the flow. But the idea is that the orchestrator task is directed and sent to the multi-agent system, so to the orchestrator. Okay, while the agent task is sent to the agent, while data task is sent to the data handler that we have seen before. So we have a backbone that is a composition of a broker and a cache. The cache is distributed in this case, is Redis. So we can exchange in Kafka only triggers, events, while we can exchange in the cache the heavy messages, the results of the in this case the queries, the output of the agents, and then each component will be able to just join all these points together. So let's just see better how it works with another slide with a completely different flow. So here we can start from the user. Okay, the user is able to send a new message to the user APIs, so to the platform APIs. Okay, now this component will convert this run pipeline command into an orchestrator task. This will be sent over Kafka. Now, this is simplification, of course. We have two perspectives of the same thing. This is logical. The previous slide was physical. So here the platform APIs is sending a message to the broker. The broker is basically here, and then the broker is able to distribute the message to the multi-agent system. Then the pipeline, as you can see here in the bottom, is simple, is two queries, the square blocks, the blue square blocks, and then we have two triangles that are the agent task and then the finalization, okay? So the multi-agent system is able to know that in this case we have two data tasks. They are sent to the data interoperability and storage. That is what we have seen in the first slides, okay? So the databases. After the completion of the data task, we have the agents. Nothing else. Now, the agents are able to receive these messages because they are coupled with a particular component, a meshing component that is called proxy. Let me only come back in the previous slide. The proxy is this one. Okay, so the agents are general. They are containers deployed in our platform. So they are blocks of code, built blocks of code. And in the deployment, we just merge and couple the proxy to the agent. So we will have in the platform a set of couples, a set of agents plus proxies. One agent, one proxy, nothing different. As let's say traffic or other also linker, as Kubernetes, as the Kubernetes mesh paradigm is able to learn us. Okay, so we have this proxy. The proxy is able to manage everything. Everything will be able to connect with the cache. We will be able to connect to the data handler. So the proxy will have certificates, will have connection strings, will have secrets, will have basically the code also to connect with the other services. And the same is valid with the multi-agent system. The orchestrator inside has a simple proxy, and the same with the platform APIs. Okay, in these cases, the proxies are embedded. In the case of the agent, not, because the idea is that everyone can send us the container that has to expose two standard APIs. Then these APIs are matched with the proxy, and they are deployed, and they are can access in general to all the platform functionalities. So now I would like to give the floor to Anna that will basically explain you what does it mean in our case embrace the AI developers and the users with a lot of ancillary services.
Hi, thanks, Nicolo, to give me the words. Just to summarize what Nicolo says, all the components that Nicolo explained in details in the previous slides represent all the distributed service that the platform must expose to handle the agent execution, workflow execution, and all the communication with the data coming from the pilot. To ensure that all this communication and this orchestration works efficiently, we need to add another number of services that was more or less the same number of the core services to investigate and manage the health of these endpoints. So in this case, we have a lot of services that were used to orchestrate all these components, and we use another amount of services to see and investigate and monitor, especially the services in the core services of the multi-agent platform. For this reason, the FLEXIndustries platform has these components that help us to be aware of the status of the systems. Indeed, as we say always to our partner in FLEXIndustries, we are not a cloud provider, so we offer a service with all the server and all the deployment platform where all the agent must be executed. But sometimes we are not aware of the problem that can happen due to miscommunication between components. For this reason, we start to think about ancillary services that help us and also the platform to be aware of the status of the systems and try to perform some action in time in order to avoid to make the service unavailable for a lot of times. So for this reason, we can see in this slide that the first layer on the top of the slides was represents all the components that Nicolò investigated in details, and all the other services that we present in the slides are all the component that helps us to investigate and monitor the platform. As Nicolò says, all the platform components, so services, core component, and monitoring component, are deployed in a Kubernetes environment that help us to assure that all the pod are a sort of group of containers in Docker, as the previous speakers explained in details, and Kubernetes help us to orchestrate this component in order to help to avoid that the services is not available for so much time. We use together with Kubernetes also Longer, that was used for the persistent data of the single container volume. So the data of the containers that could be log or information that or information of the data that are stored by the services, and also GitLab as sort of repository when we can store all our codes, deploy our container, and use it to deploy easily our platform. So the idea is to have this infrastructure and operational layer that was distributed to all the services component. Then we have a second layer that was the pipeline management layers. Also in this case, these services are developed by us. So the pipeline inspector is used to inspect if the pipeline execute all the single steps that we plan. So for example, if we have to execute 2 agents through this pipeline inspector that is a small dashboard, we are able to see that all the agents are executed, or if sometimes the pipeline remains stuck, we are able to understand where it is blocked and how to solve this problem. The quota controller is a component that controls the number of requests that comes to our platform in order to avoid that, for example, bot or something like this, or some users like this can access to our platform and make a lot of requests that can block all the services. Then we have the pipeline scheduler, that is a sort of component that was used to schedule the pipeline. So it's used it's a request from the partner that use the platform to help the use of it in order to ensure a schedule of the pipeline in time periodics, once a day or something like this. And finally, we have the auto retainer that was a complex component because help us to retrain the machine learning models that sometimes need to be retrained because the data that they receive are very different from the previous data or the historical data. Indeed, in our case, we have a lot of components that optimize the process optimization of a plant. So during the process production of a component, and the value of the energy that was used for product this product sometimes could be very, very different due to the renewable energy sources that can change very frequently during the year and during also year by year. So for this reason, they need a frequently retrainer. Instead, in the last 2 layers, we can see the observability part and the identity and security dashboard. All the services are secure with all the communication between services, and also from the external are secure through the quick lock tool. And we also use for the dashboarding Grafana. Headscale was used to secure the communication with external services and also external virtual machine that were used for some specific task. And instead, we have Loki, Jagger, OpenTelemetry, Prometheus that were used to monitor all the platform and also to investigate the latency between the communication between components. Indeed, we produce a paper which talks about this platform, and we need to understand how the performance of this platform are better with respect to the other platform. And we noticed that the time of the communication is very low, and we noticed that even if the cache could in some way reduce the amount of data that comes into the broker. It helps to improve the communication because the communication in the broker Kafka will be very fast. Thanks to this reason. So we use it to improve our platform and also to understand if there are problems, to receive alert, and to fastly solve this problem. Finally, we use the platform operator that helps us to automatically deploy all the components in a easy way and also very, very fast. This is the whole architecture. This could be a bit strange in this moment because we see all this part in specific and in details in the previous slide, and we have in this schema all these components in the same schema. We can say that all the components that Nicolo talks are the one in orange and are the core component of the platform. That all these components communicate in Kafka. That was our core communication backbone, and all the other communication between the other components happens through the network of the pod in Kubernetes. So in this way, we can see that all the platform is completed, and we have all the single services. So the data orchestration, the data gathering, the data processing, and then we have pipeline management, platform integration and visualization for the monitoring and ancillary services. Here we have a small use case explanation that try to represent how our platform works in real context. In this case, we have these objectives, that is improve energy flexibilities and optimize energy consumption inside our pilot. The pilot in question is Sun Pharma, the pharmaceutical partner that was one of the 5 pilots of FLEXIndustries. The idea is to try to achieve the goal that was to optimize the process and the schedule of the process inside the plant. To achieve this goal, we need the output of different layers. So in the first case, we have first we retrieve and store and collect all the data coming from the steam, the cold water, and electricity. These data must be processed before sending it to the agent that make the forecasting of the variable in question for the next day. So this data, after the forecasting of this variable, we merge the forecasting of the variables of the steam, cold water, and electricity of the next day with the data forecasting of the energy price, electricity price forecasting, natural gas price forecasting, and also the photovoltaic panel production forecasting. So for this reason, all this output of these 6 agents will be collected and merge and send to the data optimization process planning agent. So we have in total a total of 7 agents that works together to produce a final output that represent the process planning of the next day. So how to effectively orchestrate and integrate the single process inside the plant to have a process optimization that reduce the cost of the energy and maximize the renewable energy uses. So these are the main conclusion. FLEXIndustries try to demonstrate how industrial data can drive smarter energy decision, and we try to demonstrate it using the data coming from the pilot that are real data. The digital twin that was represented by our multi-agent systems platform enable actionable industrial intelligence. All the platform is event-driven. So as Nicolo says in the previous slide, all the communication between platform component is event-driven, and this helps to be asynchronous and stateless. And finally, we can say that the multi-agent coordination is supported and based on the distributed microservices architecture. That is an important paradigm that allow to have a good failure solved. And finally, we have that all these tools are Kubernetes and user-oriented, so can be easily deployment, easily usable, and also very resilient in terms of persistency. So thank you for the attention, and if you have any question, we are available to answer to all of them. So.
Thank you so much to Nicolo and Hannah. Have any questions? So we have seen various presentations on different tools and platforms. It's not always easy to introduce flexibility and digitalization and decarbonization in various industrial sectors without compromising productivities and some challenges. We face some challenges as in TRINEFLEX, sure, but probably also in FLEXIndustries. The main challenges, I think, are the data collection, as Nicola mentioned, that is very important, the standardization of the tools, and also the collaboration with the industrial sector. So we think that the comments and questions from stakeholders, especially those not involved in the two projects, can be very, very useful to update our tools. And so now is the time for your questions, but also for our to ask. So I leave the floor to Leonardo to ask some questions to you participants. So I leave the floor to Leonardo.
Thank you, Michela. Hi everybody, I'm Leonardo Improta. I'm a communication officer at Icons Innovation Strategies, and I'm leading the communication and dissemination of the FLEXIndustries project. I would like to hear your voice now. I mean, I get that this presentation could be difficult to understand, but you're all expert in the field, and it might be difficult to raise some questions, and you get to first absorb all the content that you've received from our speakers. But it's now time to interact and to get your voice and to get your opinion. And that is why I created a Mentimeter. It's simple Mentimeter, just like 4 or 5 questions. So it will take you only 5 minutes. So please, I will ask you to scan this QR code, or either you can access the Mentimeter by the link that I'm just sharing in the chat. Also, the speakers can attend the Mentimeter and join, so that it will be more interactive and we'll gather feedback from all of you. I will wait a couple of minutes to let everybody in. I can see that we have 18 participants, so the number is increasing. I will wait a couple of seconds and then I will start the slides. Again, those are just quick questions. We would like to hear your feedback from concerning the presentation that we have performed with you today, and the platform that we have presented both from the TRINEFLEX project and the FLEXIndustries project. I see numbers are raising, so we have now 23 participants. I think we can then move on to the first question, which is, do you see the advantages of digital platforms based on the presentation that we have provided you today? And also based on your experience as an expert in the field, I would say that this is kind of an easy question, and I can see already from the respondent that it might be an anonymous opinion saying that digital platforms are an advantage especially when dealing with flexibilities in industries and plants. So I see that already 13 of you have already responded yes, 14 the number is increasing, and again, yeah, based on all your experience, we can say that digital platforms are an advantage, definitely, especially when dealing with flexible industries and flexibility in general. Let's wait for everybody to respond. We have 19 out of 30 people who responded. But yes, so again, this might be an easy one. So I will probably move to the next slide, which is an open question. What are the main advantages of digital platform for energy intensive industries? The one that you foreseen, the one that you have experienced, the one that you could share with us just in a few words, like optimization, AI, I can see here, data. We have several advantages coming from digital platforms, and we would like to hear from you. What are these advantages in your opinion? We will also eventually use this feedback from you to possibly further improve the platforms that we have developed within our project. I can see that data is the preferable choice, let's say. I can see also some interesting other reply, such as scalability, collaboration, energy efficiency, standardization as well, optimization, flexibility, efficiency. A lot of interesting words and aspects that definitely are an advantage when using a digital platform for energy intensive industries. The user involvement, its effect as well, absolutely. Vendor operability, I can see that. Predictive maintenance, which is a key actually. Thanks to digital platform, this is actually possible. Cost saving as well, that's a fact actually, because when you control data through digital platform, you are also allowed to save something in terms of cost, definitely. Not anticipate problems as well, which is also linked to cost saving, I would say. And scalability and collaboration, again, energy saving. Those are all interesting answers. Thank you for that. I will now move on to the next slide. What are the main barriers now to digitalization in energy intensive industries that you foreseen and that you experienced based on the work that you're performing, also in your project, but also in your daily work life? What are the main barriers that you see are key and needs to be addressed as of now when we talk about energy intensive industries? Owners, digitalization, which is an advantage, but it's also a barrier. Definitely. Vendor lock-in, integration complexity, this is a fact. The fact that we have fragmented digitalization concerning all the industries that are within Europe and in our world, and fragmentation will definitely affect we need to standardize more and more in terms of digitalization in order to align with others and communicate with others. I can see here data availability and data collection. This is also a fact. Everything related to data in general, I can see data acquisition, data management challenge. And here, in this way, I guess that digitalization is, as you already presented, both an advantage, but also a barrier. It could be, let's say, the solution for most of the problems and most of the challenges that we have foreseen and we are facing in energy intensive industries, but it comes with problem, with challenges as well. So I can see here not easy handle of data, switching costs, lack of digital skills as well, legacy system, integration challenge, open data ownership, resistant to change as well. This is a fact, absolutely, because when we were comfortable with a setting and with workflow, then it's difficult to change it and to switch into something which is probably more effective as digitalized, but needs to get to be understand, and we need to get used to it. So it's definitely a fact. I can see your legacy system and data availability and high initial costs as the three main factors that has been raised. This is definitely understandable. Digitalization comes with costs and comes with how to align with the legacy system that we have used so far. So this is definitely a thing. But those are all interesting answers. I will now move on to the next one. What are for you, and based also on the experience that our speakers have shared today, the three characteristics that a platform must have when we speak about energy intensive industries? So what are like the three factors, three aspects that a platform must have, in your opinion? You can think about your platform if you want. You can think about a possible functioning platform that you imagine could be effective based on your plant. I can see here data, usability, and monitoring. Those are three interesting characteristics and definitely fundamental for a platform to be effective. I can see interoperability, security, and user-friendly. The user-friendliness, it's a fact, and it's linked to the challenges that have been raised before. Easy to use, again, versatile, and security. Scalability, interoperability, and real-time data analytics are key platform characteristics for energy-intensive industry. I can see here interoperable, operationally reliable, and secure by design. So this aspect of security is coming more and more often, and it's a fact, definitely. I can see security mostly in all the replies that we are receiving. So it's a pattern. It's I would say a common aspect from all your opinion when it comes to platforms and digitalization in energy-intensive industry. I can see friendly and user-friendly and usable and reliable as key aspects as well. Especially if we are talking about some barriers that may come when it comes to digitalization. The one we were talking about before, the fact that we are used to control and base our workflow with certain systems and technologies and methodologies that may be obsolete, and the digitalization come with challenges, obviously. But friendliness and security are the key aspect, I would say. And now to conclude, are the platform that we presented today applicable to your company, in your opinion? Think about all the characteristics that we presented to you today. And this is helpful for us to understand the scalability and sustainability and post-project plan in terms of the platform that we've developed within our project. This is key for us. I can see most of you have expressed yes, but also some of you have expressed the fact that they need further development. This is obviously understandable. And it might be useful to hear after we close the Menti from the one who replied that this platform is further development, which are for you this development that this platform may need in order to get a fully, let's say, applicable to your company. I can see that nobody replies no so far, and this is a good sign, meaning that what we are working on in our project, it's definitely something, and it's definitely an advancement, and this is good to hear. But yes, with that being said, I will then close the Menti and leave the floor again to Michela for the conclusion and the next steps, and some reflections also from all the results that has been raised from this presentation and this Mentimeter. So thank you all.
Thank you also from my side. Thank you to all the speakers. Thank you all the participants, and also for the interactive section. If someone has already some question, can write in the chat. We will send you the link to the event recording, also with the presentations and the results of Mentimeter. And I will be continue to update regarding our projects, their progress, and so event, including the final conference, because we are both TRINEFLEX and FLEXIndustries are the last year of the project. And yes, again, thank you everybody, and see you. Keep in contact, and see you soon.
Thank you all. Thank you to the speakers as well.
Thank you.
Thank you.
Thank you very much.
Thank you very much.